Okay, circuit elements. Let's continue talking about what is circuit elements. We have here a definition. An element is the basic building block of a circuit. So let me write it down so we can have a note here. An element is the basic building block of a circuit. Okay, so an element is the basic building block of a circuit. So in this circuit here, this is an example of a circuit, and so we can find the amount of elements that are in here. So we can say that this is one element, this is another element here, this is another one, and finally we have the last one. So that means that this circuit consists of a total of 4 elements. Okay, so there are 4 elements in this circuit because we are studying circuit elements, and we came out with a definition that an element is the basic building block of a circuit. So we don't care what type of building block in this moment, we only care of how many building blocks are there in the circuit. So we see that there are 4, so you can name them 1, 2, 3, and 4 blocks. So let me write another piece of note here. So an electric circuit is simply an interconnection of elements. So this diagram here is a circuit. And why is it a circuit? It's a circuit because it applies the rule of an electric circuit is simply an interconnection of the elements. Okay, so this is a circuit because the elements are interconnected to each other. So here these lines symbolize wires. So we can say that this element is connected to this element, this other element is connected to this one, and these two here connected to this one here. Same thing with this, 3 elements are connected in the same point. So we have that these elements here are interconnected. So that's the meaning of an electric circuit, is simply an interconnection of elements. So we now know that what is an element, we know what is a circuit, so we can further our concept with identifying what type of elements they are found in a circuit. So we can have another piece of note here. Let me write it in black now. There are 2 types of elements found in electric circuits. Those are the passive elements and the active elements. So let me write it here too. There are 2 types. Here are 2 types of elements found in electric circuit, in an electrical circuit. Okay, so one of them is the passive elements, and the second one are the active. Okay, so let's study now one of each of them individual and go a little bit more further. What are these elements? Okay, the passive and the active. So let's change the slide. Okay, let's study the passive elements. Okay, we have here some example of passive elements. We have resistors that can be symbolized with the letter R. So here, if we have a single phase diagram, or if we have here a diagram symbolizing elements, we can symbolize this resistor as, let me have here an ink, so we can write this symbol of this resistor like this, having an R representing resistor. Now in this other one we have some capacitors. So what are the symbol of a capacitor? We can use it like this. Okay, and that's with a capital C. Same thing with the inductors. We can have the inductors with a little symbol like this, and that will be symbolized by the letter L. So wherever you see R, that's a resistor, capacitor C, and capital L for inductor. Let me write the name here at the bottom so that the name is here. So this is resistor, this is a capacitor, and this is an inductor. Or you can also, so that it could be remembered, it's a coil. Okay, so here we have different type of coils in this figure. You can say this one is the most common one, but even though these one are also used in different circuit boards and different applications. Same thing with the capacitors. The capacitors are different types, different sizes and different rates. Same thing with the resistors. So these resistors, capacitor and inductors are under the passive elements. So what is a passive elements in conclusion? So before going to that, let me give the units of each one of those passive elements, so we could continue with the study of elements. Okay, we have the unit for resistor is the ohms, or the and it's symbolized by omega. The unit of capacitor is the Henry. Sorry. The unit of capacitor is I made a mistake here. Is not Henry, but is Farad. Okay, Farad symbolized capital F, and the inductor is the Henry. So I made a mistake there. Please excuse me. It's the Henry. Capital H. This is R. Okay. All right. So now that we have the unit, the symbol, the name of each passive element that are provided in a circuit, let us give a definition for what is a passive element. So let me have it here. A passive element or passive component cannot provide power gain or is not capable of generating energy. So let me write it here. It is an element um, who isn't capable of generating energy. Okay, it's not capable of generating energy, so that's the behavior, or that's the rule of a passive element in a circuit. Another name that it can be called, it's a load, can be called a load because it only absorbs power, it do not supply power, so it can be called as a load. So that's very important to distinguish between a passive element and an active element in a circuit, because depending on what type of element it is, it has a specific type of behavior. So let me continue with another slide here. So that the active elements now, and we see some example here: generator, battery, um, any source that provides energy to the circuit or provides a power gain to the circuit, it's considered as an active element. So let us write here a note regarding an active element. So I can say here that an active element or active component behave as a source. Behave as source of power in the circuit. Okay, so another name, another title that we can give to source of power, it can be generate. It's capable of generating energy. So uh, okay, there it is. So we have that an active element behave as a source of power in the circuit, capable of generating energy. So that's very important to notice the difference between an active element and a passive element, because depending, again, as I said, of the type of element that is in the circuit, that's the type of behavior or analysis we will be observing of regarding that element. Okay, some examples, as I said: generators, batteries, some semiconductors, transistor, operational amplifiers, and so on. So there are many, right? In this case, we are looking at some that are the most important. And let me have here another note. So the most important active elements are voltage or current sources that generally deliver power to the circuit connected to them. So there are two kind of sources: the independent and the dependent sources that we were going to be looking at those in another video. So let me just write some note here. The most important active element, or we can say the most common, or the one that we'll be studying the most here in these courses, in these basic courses, elements are voltage and or current sources that generally deliver power to the circuit connected to them. Okay, so and we have two important sources. Those are one and we call as the independent, and E, and two dependent sources. Okay, so as a review of this slide, you can have that active elements behave as a source of power in the circuit, and then the most important active elements are voltage or current source that generally deliver power to the circuit connected to them. And we have two main important active elements. Those are the independent source and the dependent sources. So let's look at them in another slide. So the symbols for independent sources, let's have the first one. So we have some independent first that do not depend in other type of sources. So they are by itself after generation or generating energy. So we can say that these two are symbols of independent sources. So we can name this as um, this two as this can be named as A, this can be named as B, and both of them are, I'll put it here, both of them are voltage sources. Okay, being um, A, we can, it's the same as having plus minus B, but if you notice something important here, this small v, and then here we have a capital V. Whenever we have a small v or a small letter for a variable in electric circuit, that means that you can use it as a non-constant or not or varying in time. So we can say that this can be used for constant or time varying voltage. Okay, so this means that this is varying in time. It can be constant or it cannot, but it can be used in both circuit for the same purpose of saying that we have a DC voltage source, and B, well, as used for constant voltages. So the capital V stands for that's constant. It will not change with respect to time, or it will not vary in respect to time. It's constant. So it's used for constant voltage. Okay. Alright, so in the other hand, we have another independent source, but this is not longer a voltage. How can I know this is a voltage? Because we have a magnitude here, we have a magnitude, and we have a polarity inside. Magnitude and a polarity. And here we have a direction, the arrow is the direction, and then we have the magnitude. That means that this one is current source. So we have here a current source, and this current source is also an independent source. So we have the most two common and important sources, independent sources. We have the voltage source that can be represented either or by a circle and a positive and negative sign inside, or two little bars, one longer than the other. And then the current source can be representing a circle and inside an arrow. This arrow could be going upwards, or it can also be drawn going downwards. So it depends of the flow of current. Okay, so it could either be drawn this way or this way. It's the same thing. The only thing that would change is the direction, and the direction will refer if it's a positive or a negative current flowing through the circuit. Okay, I believe that's clear enough. Okay, let's continue with the last slide. Yeah, I think this is the last one for this video. So I don't want the video to be too long and too boring. If it's going too slow, you can fast forward. If it's going too fast, you can reduce the time of play. Okay, symbol for dependent sources. So we have here two symbols of dependent sources. As its name says, those sources depends on other sources that are in the circuit. We will be studying these sources more detailed, along with some more advanced and topics, or not advanced, or more details, that may I say. So let me have this here. Okay, so this one, let me name it A, let me name this B. So for A, we have that A is a dependent voltage source. Why? Because if you notice, we have magnitude and we have polarity, plus and minus. Okay, and for B, we have that B is a dependent, okay, current source. All right, because we have magnitude again and we have direction. This is the direction, it's flowing that way. So I will leave this video until here. In the next video, we're going to study in more details the different type of dependent sources, how they work, numerical analysis, and we're going to further on some more concepts that are very important in engineering, electrical engineering sciences, so that circuit analysis could be easier for more complex configurations and understanding. Okay, I think that's it for this video. Okay.